Eric Simmon from NIST. He works with the NIST Cloud Computing Program. He's going to be talking about some of the specific work that we're doing and that he's doing on cloud service level agreements. Eric is, he also for the other part of his job, works on cyber-physical cloud computing in collaboration with some other industry partners in the NIST Software and Services Division. So with that, I'll let you take it away, Eric.
Thanks, Bob. Today I'd like to talk a little bit about cloud service level agreements, what they are, why they're important, why what we have today is not sufficient, and how NIST is working to address those deficiencies. I'll start by giving a little background in NIST and our activities regarding cloud computing, and then talk about SLAs, the issues, and finish, as I said, with a discussion of what we're doing to address some of the issues. Is everybody familiar with the Vivek Kundra Federal Cloud Computing Strategy document? So it lays out some recommendations, some reasoning for why cloud is good. It really comes down to three different areas. It's efficient, better use of resources. It makes it easier to use, increases productivity, and finally, it encourages innovation. And he has 9 points, but those three, I think, sum it up pretty well. So along with these reasons and the discussion on how we could migrate to the cloud, that document tasks NIST with assisting the federal government in its effort to move a percentage of cloud services, or a percentage of services and applications to cloud services. We were tasked with two main areas of focus. The first is to develop a roadmap to assist the federal agencies in making this migration, looking at what the present issues are and how to provide them with some ideas on how to resolve those issues. And then the second aspect is to go ahead and then lead efforts in both trade organization and international organizations to improve standards that support cloud, and specifically work with all the different stakeholders, not just the standards bodies, but not just government stakeholders, but industry stakeholders as well. This, of course, fits very well in with the NIST mission, which is focused on advancing measurement science, developing standards, and supporting technology, but to support U.S. innovation and industrial competitiveness. So at NIST, we've been working for a few years. We have a cloud computing program. Bob's leading that effort. He's the program manager right now. We have two parts of the roadmap published. The first one is the one that lays out those requirements that I mentioned and the issues, the barriers, shall we say, to moving services to the cloud. The second one has some other additional useful information, the most important of which is the reference architecture portion, which many of you are probably familiar with. I think importance in today's discussion is the requirements. These are the high priority areas to address. There were 10 of them. They talk about such things as international voluntary consensus standards, improved security solutions, federated cloud environments, the ability to meet specific USG requirements. We've actually found that for almost everything, even if a requirement, there isn't a regulatory requirement for business partners and business customers, that what needs to be done is still essentially the same. And business, so what we're doing to develop cloud standards and help support U.S. government is equally applicable to businesses. So again, that really helps, works well with NIST's mission and ITL's mission. There are two of these requirements that are, one's directly relative to this conversation, one's indirectly relevant. The first is requirement 3, to develop technical specifications, standards for consistent high-quality service level agreements. We identify that there are no standards for service level agreements. There is no standard vocabulary or definitions. And if you look at the variety of SLAs out there, it's hard to compare them because there isn't consistency. And the second requirement is a requirement for cloud service metrics and measurement capabilities. There are two aspects of this. One is standardizing on units of measurements. And the second part is linking these to the elements in the SLAs as defined in the standardized in requirement 3. So I mentioned our cloud reference architecture. Everybody's probably familiar with this. It goes ahead and defines the roles of the different actors participating in a cloud ecosystem. The two primary actors are the cloud consumer and the cloud provider. Those are the two to which a service level agreement is of most concern. The other actors are supporting actors, but the service level agreement is between a provider who's providing the service to a consumer or a customer. Now we're getting into the details of SLAs, and some of you might be wondering what an SLA is, and to tell the truth, I'm still wondering that. There's many different definitions and different perspectives of what an SLA is and what it includes. Here we have two different definitions, one from an ISO standard. It lists an SLA as a documented agreement between the service provider and the customer, or in our case, the cloud service provider and cloud service customer, that identifies the cloud services and service targets. So it's not very specific about what's in a service level agreement. Now, in the NIST Cloud Definitions document, Cloud Service Level Agreement is defined as a document stating the technical performance promises made by the cloud provider. It also would define how disputes are to be discovered and handled and what the remedies are, what the compensation is if the technical performance is not met. And if you look at the majority of actual service level agreements, they tend to follow the second definition. They focus on the performance of the service, hence level. There's often other contracts that cover these other issues. We can really break it down into three different types of agreements when you have a contract between a provider and a customer. You may or may not have all three of these, depending on the complexity of the services that you're buying. If you're buying just one, you might just have a service agreement and a service level agreement. If you're buying multiple ones, you might have a master service agreement as well. The master service agreement covers all the generic contractual language between the provider and the customer. The service agreement then defines the requirements and the contractual agreement for the specific service that's being provided. And then the service level agreement provides the performance levels for a service. And you may have one service level agreement that maps to more than one service agreement. And if you have a master service agreement, then you probably have more than one service agreement as well. So it can get rather complex rather quickly. So why is there a problem with existing service level agreements? Well, there is the problem that people don't know what they are. Don't know whether they're service level agreements, whether they include non-functional requirements such as confidentiality requirements, security requirements, support requirements, or if it's just focused on the performance. Another issue is even when they're describing the same concept, different providers use different terminology. Or they use the same terminology with different definitions. And I think the most ubiquitous example of an SLA right now is availability. And almost every cloud service provider defines availability differently. And often it's not sufficiently defined as well. So they define it in a very ambiguous manner that makes it very difficult to verify whether or not your performance needs are being met and to get any remedies if and when you feel that you're not getting the service you purchased or paying for. So it's a different language. There's not providing assurances that the customer's needs will be met. And finally, often the remedies are not sufficient. That when it goes down, your business, your agency is impacted in a far greater manner than you're compensated for by the cloud provider. I have to say, we at NIST can't really do anything about that part. That's between the customers. Customers really have to push the providers to be really willing to back up their services more. We can work on the other two aspects. And now I'm going to step back a moment and talk a little bit, take a bigger picture, and talk about how SLAs don't really exist by themselves, but they're part of the whole process of purchasing and using cloud services. So the first part actually begins before you purchase anything from a provider. The first part is understanding what your requirements are, what goals you're trying to achieve with the service that you want to acquire. Now, that's actually harder than it sounds. Once you've decided on your requirements and understand your requirements and goals, then you need to match those requirements to a service and determine the best service and best service provider to meet those requirements. That's the first phase, the first part of the cloud trifecta. The second part, once you've decided on a provider, is to go ahead and form those agreements. The master service agreement, the service agreement, the service level agreement. That is not just for the customer, although it seems like a lot of providers these days treat it as such. But I think ultimately this benefits the provider as well, because they want to provide a good service. They want to make the customers feel comfortable, and they should have them be assured that they can get what they need to meet their business requirements. So we're good for both the customer and the provider to improve the existing SLAs, to improve on the existing SLAs. Now last, but definitely not least.
I was going to say they could also use that as an advertising point that says we adhere to this system of standards for SLA. So when we say this, you know what we mean. So when they can use that in advertising, that's always another push for them or another benefit for the provider. Although they may not see that exactly right away, they might have to be convinced. But
so that's very interesting, and we're getting into a discussion of that. Go ahead.
Just another question since there's a chance there. These are not new problems. They've been around for at least 20, 30 years, what you're describing, SLAs and so on, how to work with it. What makes it different for the cloud computing?
What makes it different for the cloud computing?
I mean, you could go, I can remember, 20 years ago, 30 years ago, writing a service level agreement for communications. And these are the same parameters. Why is this a different ball game? That's what I'm wondering.
In a lot of cases, it's not any different. It may be more critical in these cases. In some cases, there are specific requirements that are needed, performance levels and types of performance properties that you want to measure that are specific to cloud services.
So it's not a whole new area is what I'm saying.
well, I'm sure a lot of the foundational work can be reused and repurposed, but there are a lot of specific instances with cloud that don't really map back to like old things. Like you might have shipped your data off to some provider, whoever was giving you the service, but you weren't accustomed to him saying, now I'm going to make 5 copies of it and spread it across the U.S. Right. So that's brand new. And then if I only shipped it to one guy and I said, I want you to destroy that data, I know he could destroy it. What is he going to do with those other 5 copies? What assurance do I have about data deletion and stuff like that? So a lot of the problems, I've been looking at that exactly myself and trying to find the nuances or the new pieces of it too. Yeah.
Okay. Thank you.
You're welcome.
I was going to agree with that because I think that the distinction here is the vehicle of an SLA, right, not new at all. A contract isn't new. Particular deliverables, performance requirements, not new. But we don't have a body of knowledge about what it means to work in a cloud environment, right? So the service being provided is brand new. So as purchasers and consumers of the service, we don't know what to watch out for. There's no body of law around it yet either, right? So give us 5 or 10 years, and the courts will play a role, and each one who suffers at the hands of a poorly crafted SLA will teach the rest of us, right? So I really am so, it's such a help that NIST is looking at this, using the vehicle as an access point to get us to some of the content in terms of how do we want to, what content do we want in the SLAs?
And that's what we're focusing on. A lot of our SLA development work is not what an SLA is, but what are the SLA, the cloud SLA elements. And I'll talk a bit later on about developing building blocks that then can be put together in whatever way the provider and customer desire. The final part of the process is the metrics and measurement portion. And this is a part that is, again, like the SLAs themselves, measurement in cyber systems, measurement for services and across diverse distributed networks has been something we've been doing for a while. It's also something we don't do very well. It's very difficult. I spent many years doing physical metrology, and that's much easier than trying to measure things in cyberspace. But then cloud, on top of those issues we've been dealing with distributed systems and service-oriented architecture, adds another level of complexity. And if you see what's being done right now, there's not much, and it's needed. Because if you have an SLA, what good is it if you can't show whether it's being met or not? So if their provider says they'll give you 99.999% availability, and they don't really define what that is, and they don't give you any way to measure it, how do you know when it's not being met? And the really nice thing is this actually loops back to the decision making, because if you codified your requirements in the SLA and the other supporting documents, and then you have metrics to measure whether you're meeting those, you then know whether you're meeting your business goals and business requirements as well.
So that was part of my question. If this is all being worked out at the time of an SLA, are people's RFPs just really general and vague in terms of what service they're hoping to procure?
Right now?
So does the SLA get worked out after you know who your vendor is, right? You know who's the cloud provider, right? So if you're in a federal setting, you need an RFP out there so that various people compete. You have to say, here are the things I care about, right? So do you know what I'm getting at? It's interesting that there are no metrics and that we're not even sure of the element, and yet many times a day, cloud services are being procured by federal consumers based on an RFP or some other request for proposals or input from vendors, but we don't have these parts nailed down.
That's a really good question. And what's being done right now, and what I have experience or information from one government agency, and they went to procure cloud services, and they gave at their acquisitions department a rather specific list. I mean, and they still have challenges because we don't have the standard definitions and everything to use. We don't have the metrics to then measure it, but they went through and put, as many of the requirements as they could in their request, which they sent to acquisitions. Acquisitions basically ignored that and just went out and picked the services, and the contract that acquisition signed doesn't have those requirements in. So there's no guarantee the agency will get what they want. And I think there's a lot of cases in business that it's the same way. And it seems extremely risky. I would not want to risk my business on a service that has the service level agreements that are being provided by cloud services. Unfortunately, I don't have to actually do that purchasing. I get to try to solve that problem. I hope everybody else does.
Well, I want to mention also that the other work that Eric leads, was really pushed by industry to get standardizations in SLAs. And I'll let him continue, but they recognize that themselves and that we all need it. So, yes, exactly. So they recognize the flaw in that diagram, too, is that there's nothing really solid to hold on to. We know what we would like. We would know how we would like to define it, but now we have to get it codified or whatever.
Right.
So I will also agree with or make another comment on that, and that is that it seems like our federal procurement process needs to change to be better suited to purchasing services rather than assets. And that's something that we hear over and over again. And again, this doesn't have, we don't do that. However, maybe we can provide these pieces that will help when change does come about. And if they exist, then like this agency could have gone to acquisition and say, here, I've used these standards, these are the standard SLAs, you should get this, and then it's easier for acquisitions. So hopefully this will help. But I think the procurement process is going to have to change too. So I'm going to go into a little bit more detail of what NIST is doing to address each of these three parts. The decision making, and it's very critical. We're working on two projects that are designed to help out there. One is our third volume of the NIST roadmap, and that's technical considerations for USG cloud computing deployment. Again, in most cases, we're keeping this general enough that it's as useful for businesses as it is for agencies. We're going to go into some details just about issues that you might have with different types of cloud services. We look at different types of infrastructure as a service, different types of platforms as a service, and different types of software as a service, and provided some guidance on things that you might want to look out for. We also have some discussions on brokering and interoperability and SLAs and that can assist a business manager or a USG agency officer who's looking to purchase services and understanding what's available, what is provided, what to watch out for, and help align with their requirements and goals. We're also working with SISMIC, which is a Cloud Service Measurement Index Consortium. I transpose the words there. That group is doing something that's very interesting as far as trying to quantify services. And so then if you've understood what your business requirements are, it's providing a way of assessing the different providers to see how it meets your needs. So, as I said, it's a quantifiable way to assess cloud services and specific properties of those services to match them against your business goals and business requirements. It's, I think, very well done in that it allows you to weigh the different properties. So you can decide, is security your high priority, is something else a high priority, and then you look at what each service provider can provide in different types, different areas, attribute areas, different categories, and weigh them, and then you can roll these numbers all up. You actually get a quantifiable, single number result that is kind of a grade for the provider, but it's specific to your requirements. The other thing that this does that's very nice is it actually is working on 3 different levels, 4 levels if you include that final single quantifiable result. It starts out with these categories, and then those categories, there's 7 categories, I think, and those categories are composed of attributes, and those attributes are composed of key performance indexes, which are your real metrics. There's 21 attributes right now. They're looking to maybe expand those and add a couple more. Right now, they've defined, and we've, working with them, have helped define the 7 categories with the 21 attributes. So the first 2 levels. The third level, the key performance index, we're still working on. That is the metrics area, and that's very important, and as I mentioned earlier, very difficult. And one of the nice things about this tiered approach is the gearheads who are under the hood, making these measurements, evaluating things, can look at that bottom level, and as you go up, you can decide how detailed to go. The top level managers that want to have to sign off on it can look at that final result, and a nice chart that explains how it's measured and how it's derived, and get a lot of information without having to go into the nitty-gritty details. There's a public version of the draft that has the first 2 levels up at www.sysmic.org. And we are engaged with a testing program with them. And they're going to provide us iPads with their tool installed on it that we'll be testing at some selected agencies in the next couple of months. So if you're interested in how that goes or want to let me know. Just to show you, here are the 7 top-level categories. The accountability of the provider organization, the agility, how easy it is for the services to change. And again, these are top levels, so all different aspects of agility would then be included in here. Assurance of the specific service that it's provided and what the provider will do to help make it reliable. Financial, how much different parts of it cost, the performance. Now that's the one that's specific to that narrow definition of service level agreements. However, all of these you'd see in the service agreements or the master service agreements. Also security and privacy, and finally usability. And here's some examples of the different attributes that are used to evaluate each of the different categories. So for agility, you have attributes such as elasticity of the service, how quickly the service itself can change, but also things like portability of data, how easy it is to get the data in and out of the service, and scalability, whether you want to bring new units on, how easy is it to go in and purchase more services, or when you're not using services, dispatch those services. So I won't go into detail about the other ones, but I think that gives you a good idea of how it's rolled up. And then again, for each of the attributes, then there will be performance metrics that allow you to measure and then quantify, come up with a quantification for each of the attributes. And then those attributes get rolled up, and then the categories get rolled up. So this is an example of one of the earlier tools, and you can see in this case the final score was a 48, and that was acceptable for this particular case. And you can see the different categories listed. You can see the different weights. This one's interesting. Agility was pretty low. Security, probably at a medium level. Financial was at the highest level. So cost was the most important criteria here. And that's seen in the final score. And you can see this graph down below helps you see relative to the other scores what the strengths of a particular service is, what the weaknesses of a particular service are. So that's what we're doing to help people make decisions and decide what services they want to purchase. Once you've done that, you still have to put your service level agreement together and form that bond, that contract between the customer and the provider. So over the last few years, we've been working on this as part of the NIST working groups. We've been analyzing service level agreements, trying to develop the concepts and understand the concepts that need to be included. Recently, we have been engaged and pushed for this at the international level. There is a subcommittee within IECASO Joint Technical Committee 1 called Distributed Application Platforms and Services. It's basically focused on service-oriented architecture. And cloud is a form of service-oriented architecture. So that subcommittee is responsible for cloud standards. So within a working group in SC 38, we've recently begun a SLA standards activity. The name of the standard, for those interested, is the ISO/IEC 19086, a Cloud Computing Service Level Agreement Framework and Terminology. So the focus is not to build a template or a form or a standardized service level agreement. There's too much variety in what's needed, and we don't want to limit the choice of both providers and customers. And this is something we like to do at NIST. I know people often think standards are bad. They get in the way of innovation. They prevent me doing what I want to do. But what we're trying to do is provide a set of building blocks that actually promotes communication, that promotes understanding, that meets people's needs by allowing them to then take the building blocks, put them together in different manners so they can meet their specific needs. So in this case, the standardization activity should actually promote usability and promote innovation. So the draft is going to include an overview of service level agreements, a set of definitions, the discussion of master service agreements and service agreements and service level agreements, discussion of service management. But the most important part is going to be the service level agreement elements. And those are those building blocks that if you conform to the standard and you use these concepts in NSLA, you have to use the language and the definitions as we've provided. And again, we want to promote flexibility. So if there are things that aren't defined, you can use them in an SLA. We're not saying you can only use what we've defined. We're also not saying you have to use everything that's defined in here, but trying to standardize on some basic concepts to, again, assist the customers and the provider in building the SLAs and understanding the SLAs, and allowing you to compare SLAs from different providers. Now, the final and extremely critical part of this is, again, the metrics. And within this standardization effort, we are going to provide a set of metrics. But we're putting that in a separate document because in a lot of cases, the metrics haven't been defined yet. As I'll describe in a few minutes, we haven't even gotten to the point of defining what metrics are, much less actually defining the metrics themselves. So, let's go right ahead.
Yeah, you must be coming across a lot of things that are probably never going to be able to be measurable, user-friendly, for example.
That's true.
Okay. Do you agree that there won't be a metric for it, or is there going to be some words in there trying to give easy, hard, or how are you going to work?
That's a good question. So right now, Part 1 is going to have those elements, and it's going to be separate, and we're not going to worry about whether we can develop a metric for it or not. Okay. Part 2 will have the metrics, and what we're actually working on doing right now is we have to see whether we can do this in the ISO/IEC process. You can do it in IEC, but it's not clear how we do it in JTC1. And that's to create a database that's updated multiple times a year. So as we develop metrics, you can add them in. And then they point to the Part 1 document that has the elements. That allows us a lot of flexibility. It means that as we come up with these new definitions for metrics, we can just use them. And we don't have to wait. We can have the elements out, we can start building the SLAs, and we can add the metrics as we get them. It also allows us to define more than one metric for a specific element. So, while it might be great if we could all come to agreement on what availability means, probably won't do that. And that's probably fine. So what we're going to do is allow you to define availability in different ways. And you just, as long as you tell people how you define it, maybe it's not directly comparable, but at least you know which ones you compare and which ones you can't compare, and you know what it means. And right now, that would be a huge step in the right direction. Hope that answers the question. Okay, and we just try to provide a few examples here of some of the elements. And again, what I've provided here is more on the level of the attributes in SISMIC. There are more specific performance indexes that are rolled up into each of these element examples right here. In the document, we split most of them out where they're appropriate. So availability, and again, the vast majority of SLAs right now only include availability, but availability is definitely an important concept. If you can't use your service, it's really not much good. So regardless of what other performance aspects you require, that's really number one. Response performance. So it's available, but it takes forever for you to get a response from the service. It's not much good either. So there's also the concept of, what is fully functional versus what is non-functional, and a lot of gradations in between there. Privacy, or from the provider's viewpoint, it's really confidentiality that they're provided, saying they will treat customers' private data confidentially. Security, which helps enforce the privacy. Reliability. Support. How does a service provider assist you when you need help? Data management, and this is one of the ones that's really critical for cloud, because you've got these shared multi-tenant environments, because the data can reside in more than one location. This creates some real issues with data management. And finally, certifications and audits is another important aspect. There's some more, but I thought this was kind of a general overview and a good set. And it's under development right now, so it will change. Just a brief timeline. This started as a new work item proposal in the spring. Yeah. It was approved over the summer.
Well, last May, yeah.
Yeah. And we actually started the work in September. I was actually chosen to be the project editor. So this is actually leading this at the international level. We just had a very successful face-to-face meeting up in Gaithersburg the first week in January, and got a lot accomplished. So we've had 2 teleconferences and the 2 face-to-faces, and we're moving ahead very quickly. I'm very happy with the work that's been done. We have a meeting in April, and after that, I think we can go to a more formal working draft and go to a committee draft where it goes out for review by the national bodies in September, or October rather, and that would put us at publication in 2015. Mm-hmm. Now, as I mentioned, I'm the project editor, and I'm very interested, and I think it's very important to get input from the federal government. So one reason I mentioned the timeline is so you know what schedule I'm working with. And so please provide input. I can provide the document, especially at this stage. I can freely provide it to those who are interested. It is a very rough draft at this point, but I'd be very interested in having people review it. Also, if there's concerns you have, specific issues that you're running into where the service level agreements are not meeting your needs, please send me an email, phone call, let me know. I'm glad to listen and will incorporate everything that I can. Okay, so the final part, and probably the most difficult part, is the metrics aspect. Making measurements in computer systems, a single computer that sits on your desk, is extremely difficult. And when you take that and throw in distributed networks and multi-tenancy cloud systems, it's extremely challenging. It gets much, much worse. But that shouldn't be a reason to say we can't do it, let's not worry about it. So NIST has been involved in a lot of work trying to understand and resolve and help industry and government in their metrics needs. And again, we can break it down. We need first to decide what definitions we're going to use, so we have a common language that we can speak when we're talking about making measurements. And then we need to actually build the measurements and metrics themselves. Because without proper metrics, as I said earlier, it's very difficult to enforce your SLA. And it's very difficult to know that your business requirements are met. So at NIST, we have a public working group that's working right now on a metrics document, metrics for cloud services. This document is the first step that I mentioned. It looks at defining the different concepts and building a model for describing metrics and measurements. Once we've done that, then we can start developing the specific instances of metrics. And the way we use metrics in this context is to describe a standard of measurement. The working draft is up on NIST Cloud Wiki. You can navigate through the reference architecture working group and the metrics subgroup to get to this document. We'll go into a little bit more detail about the concepts of metrics and how it supports SLAs and how it supports decision making. This is our decision making metrics, the metrics for deciders. We have some very famous deciders, U.S. government. You can see here we have a cloud customer who wants to evaluate whether to choose service A or service B. Well, what he's concerned with, what are the properties of those services? And if he has metrics that allow those properties to be described by the service provider in a way that the customer can compare those, the numbers that they're given, he can make an informed decision, and in this case, he's chosen cloud service B. Now, the metrics for the verifiers. Once you've already purchased the service and want to make sure that your SLA is being met, works very similar. We have metrics. Those metrics allow us to understand what the measurements are. The measurements might actually be measured by the provider, or maybe a third-party auditor or a third-party service provider comes in and provides those measurements. But the customer can use those metrics to understand the measurements of what the service is being provided, and then understand whether they're doing any remedies, whether the service is meeting their needs. So I already mentioned standardized measurements. The measurements and metrics themselves will come next. One nice thing is that the NIST group is, I think, probably the farthest ahead as far as groups, both domestically and internationally, working on this. And this work is going directly into the ISO IEC standard that I mentioned, and be used as a basis for that Part 2 metrics document. Here's just a slide showing kind of an example of the range of what different definitions are being used for the basic concept like measure. So we have 7 different definitions for measure, and some of them are diametrically opposed. We have one is a variable not the value itself, but the variable to which the value is assigned. Another is the method used to make a measurement. And so if you talk to somebody and they're using these two different definitions, you have no idea what's going on. So we can standardize on a single definition that we're using, that will help a lot. Let's get that slide. Here's the basic metrics model that we're working on right now, and provides some idea of the complexity of the standard of measurement. Ultimately, we want to make a measurement, and we're using measure as in the value that you get once you have a measurement. That term might change. But that measurement uses some measure definition. The measure definition might be a simple type of measurement or measure, such as the concept of a second, or it's more likely it's based upon underlying measurement definitions, like the idea of response time, which uses units of seconds. But even when you have the concept, the more complex concept of response time, you still need additional constraints. So response time is the time it takes from when you send an initial request to when you get the response. But where do you make that measurement? Do you make it both of them on the customer side? Do you make it on the provider side? It changes your results quite drastically if you measure in different places. Do you start at the beginning of your message? As soon as you start sending the first bit, do you start the clock? Or do you start at the end? And it's a bigger difference when you get the response. If the response is a small file, then maybe it doesn't matter too much. But if your response is, you know, a stream, how do you measure that? If it's a 2 gig or 10 gig file, maybe your performance is going to be a lot worse if you measure to the end of that file than if you measure to the beginning of the file. So these are also captured along with the measure definition to form a specific metric. Now finally, we've talked a lot about the present situation and what we're doing to fix it, but I thought it would be worthwhile to talk about kind of the next generation of cloud computing systems, and how that'll pose additional challenges for our service level agreements. At NIST, we've seen this idea of cloud service interoperability as really the next generation. When Vin Cerf came and spoke at our last cloud computing conference, he brought this up as a huge issue. You know, to really realize the capability of clouds, not only should individual services have the cloud flexibility and be service-based, but entire systems should as well. So provider A here, the first provider, provides a service to a customer, which then uses that as the basis for the service they provide to another customer, who then provides that to the final customer. And that's complex, but ideally we want to be able to switch out these lower level cloud providers at will and when needed. So that's going to require us to have a way of heterogeneously mixing these different cloud services. They have to be interoperable. But at the same time, you're going to have service level agreements that can be developed very quickly, that can be self-service, and that can be support different levels of systems as they get rolled up. And probably most important in this case is that they need to be automated and machine processable. So you don't want to have a person go in and do all of this contractual work. You need it to be machine generated so that these systems can actually be scalable and agile. And these kind of meta systems can be scalable and agile. So that's definitely the future view, but it's something we're already starting to think about.
So, excuse me, one other point is that in 5 years from now, 80% of all cloud services are actually going to be used by other clouds themselves. So that's why there's the push for this type of activity in the group. So.
Do you find there might be major differences in the result depending on whether it's for industry, academia, for research, or for government? You know, these metrics, would they?
No. I mean, there are some cases, certainly, but we've really found that there are not a lot of cases. That the vast majority are suitable for both. One that comes up frequently is privacy. You know, people say, well, the government has these very strict privacy requirements, and industry doesn't. Well, they might not have a regulation that says they have to use a certain privacy or have a set of privacy requirements, but they have the set of privacy requirements anyway because their customers want to be protected. So we see analogies like that throughout the different SLA elements. And certainly there are instances where you might have a specific requirement for a government agency that you don't have. But in general, they're much more similar than they are different. Another good example of that actually is in the auditor. And we heard a lot of feedback originally that, you know, no, there's no need for auditing in the private arena.
You don't need
and
that.
Then I was listening to the federal radio one day, and they had, I think it was the COE from DOD on, saying, well, we're using these auditing standards that we got from private industry. So, again, there's a lot more overlap, I think.
Good question. So when you're talking about one cloud using another cloud as a provider, so the assumption is that both clouds have a relationship with us, or because the thing is that if I have a relation with one cloud, to a case they're using one or two end clouds behind them, so as long as they need a relation with me. So this is what I'm trying to do.
Yep, it's a good question. And that touches in on the cloud broker concept. And the way we're defining cloud broker at the moment is cloud brokers provide transparency to those providers that are behind them. But a cloud provider by itself doesn't have to. Your agreement is with that provider. You ideally should be able to put requirements in that agreement that cover whatever is being done by the supporting providers. And then it's up to the primary provider to make sure that those supporting providers meet their requirements. But you only have the agreement with the initial provider. Then there's a case where you might want more transparency, and that's the broker concept that we discuss in different volumes of the roadmap. It's an interesting and yet challenging concept of its own. I did want to mention before I finish things up is, if people aren't aware, I also lead the Federal Cloud Computing Standards and Technology Working Group, FedKit. It's an opportunity, it started at the CIO level, but we've now opened it up to more participation. But it's an opportunity to get together once a month to hear some different agency stories and input about issues and challenges they're having as well as successes they're having, and also keep up to date on some of the different NIST activities and different USG activities. So if anybody's interested in participating in that, the conference call is every third Thursday. You can email me, and I'd be glad to add you to the list. Right now we're just having conference calls we'll probably schedule some face-to-face meetings like this throughout the year as well. Thanks very much.